Yeah, hello everyone. This is Keerthana. Today we are going to discuss about the topic is 2D transformation in graphics and multimedia. So the thing is, what is transformation? So the transformation in the sense to changing the position and shape, size or orientation of an object. So there is three kind of basic transformation we can use here. So the first one is a translation and then rotation and then scaling. So these three transformation are known as a basic transformation because with the combination of these three transformation we can obtain any kind of transformations. So we can first discuss about the translation. So here the translation is that used to reposition the object along the straight line path from one coordinate location to another coordinate location. So we can say it whether it is a triangle, rectangle or a lines. So any kind of objects we can reposition the one coordinate location to another coordinate location. So we can say it is another word, it is a rigid body transformation. So we need to translate the whole objects. So here we translate two-dimensional point by adding translation difference distance, that is tx and then ty, the original coordinate position x and y, to move at a new position x dash and then y dash. So we can call it a x dash y dash is a new translated position. Here we can use two kind of formulas for the two-dimensional points, and then the first one is a x dash equal to x plus tx to finding the x values, and then the next one is a y dash equal to y plus tx. It is a y dash coordinate position finding formulas. And then there is a translation distance pair, that is tx and then ty is called translation vector or a shift vector. So we can also use for the single matrix equation for the column vectors. So that is p dash equal to p plus t. So this one is a p dash equal to p plus t, and then x dash y dash equal to x y plus tx and then ty. So we can use this kind of matrix equation also in our problem solving things. So the above we can mention the two formulas, right? So we can use this those things as to our problems. So we can also represent in a row vector. So the previous one is a column vector and then the second one is a row vector. So we can also represent in a row vector form as p dash equal to p plus d. So x dash y dash equal to xy and then plus tx and then ty. So since the column vector represent is standard mathematical notation, and then many graphics packages like GHKS and PHIGS use the column vector, so that we will also follow the column vector representation for the matrix equation. Otherwise we can follow the above these coordinate positions we can also use for our problems. So the example here, the translate the triangle A 10, 10 and B 15, 15, C 20, 10 and 2 unit in x direction and then y 1 unit in y direction. So we know that P dash equal to P plus T. So P dash equal to P plus Tx and then Ty for the point of 10, 10. So here we can calculate each and every positions. So there is a 3 points, right? So in these 3 points it's denoted as a triangle. So we can calculate the each and every points for the translation process. So here we can use the column vector formulas. So we apply the column vector formulas for the each three position points. After the final coordinate translation rotation, we get the this kind of values. So it was translated to one position to another position. So thank you for all. Then the remaining rotation and scaling we can discuss about the next topic.